All right, so this video is going to cover 9.2, which is measuring area and volume. So we're going to go back and remember from way back, use the volume formulas and the area formulas for finding area of a square and volume of a square or rectangle and things like that. And then we're also going to look at it in terms of measurements, because when we're measuring the area of something, we are measuring length times width. So we are squaring that unit. And if we're measuring the volume of something, we are multiplying length times width times height. And so we actually wind up cubing that unit. All right, so we'll look at a few examples, and then we'll have some practice problems to do in class. So the first example I want to look at is example 1, and I think I'm going to use my text box. There we go. All right, so example 1, it says, what is the area of figure 9.4, which in 9.4 we have 1, 2, 3, 4. We have 12 squares, okay, that are lined up 3 rows of 4. So you have your book there, so I'm just going to put figure 9.4. Okay. All right, so in figure 9.4, like I said, we have boxes. Let's see if I can. Oh, I can do shapes. All right. So there's one square, and then let's see if I can repeat this. There we go. So there's another one. 3, 4, and then we have another one here, and here, 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 here. Okay, so these are all supposed to be touching. They're not doing that very well right here. There we go. All right, and one of these squares is a unit. So to find the area of that, what we're going to do is we're going to multiply the top row times the column. So the area is going to be 4 units times, because that would be our length, times 3 units, that would be our width, which gives us 12 units, but they're units squared. And I can't put squares on here. All right, so we'll have to do it this way. They're units raised to the second power. So for this Jamboard, I'm going to put my little caret and put 2. Because not only did I multiply the numbers 4 times 3 to get 12, but I also multiplied the units. So units times units is units squared. Another way to think about it is if we said that this was 4, if each one of those squares was a centimeter, we could say 4 centimeters times 3 centimeters equals 12 centimeters squared, because we're multiplying a centimeter times a centimeter, which is a centimeter squared. Okay, so that's for area. All right, let's look at example 2. So this is example 1. Example 2 says using square units to compute population density. Okay, so we have to, this is another situation where we've got to include our units, not just our numbers. Okay, so after Alaska, Wyoming is the least dense populated state. This population of Wyoming is, the population of Wyoming is 568,158, and its area is 97,814 square miles. What is Wyoming's population density? Well, its density would be how many people there are there divided by the volume of space it takes up. So here's the formula, and they give you this: population density equals the population divided by the area. Okay, so for this particular problem, you would say that the population density was going to be equal to the 5,680, 158 people divided by 97,814 miles squared. Okay, so you divide that number out, and that gives you your population density. Density always has a square on the bottom. So that's going to be 5.8 people per mile squared. Okay. And again, you have to include your units. You can't just give me a number. You have to include the units. Okay. Now, in example 3 is where we start getting back to our dimensional analysis that we talked about in the last video. Okay, and we're going to look at how we are going to cancel things out and how we do that with squares and square units. Okay, so example 3 says, and this is just straight out of the book, says national parks consist of 75,000 acres with miles of pristine surf-washed beaches. This is in San Francisco. Forested ridges and bays bordered by white cliffs. How long is the national park in square miles? So basically what we want to do is we want to take 75,000 acres and convert it to miles squared. That's what the problem is asking us to do. Now, if we have a conversion factor, that's really easy to do. All we need to do is set up our dimensional analysis. And you set that up by always starting with what you're given. And you were given the 7,500 acres. So we're going to take 75,000 acres. And we're going to multiply that, or do our little railroad tracks with our dimensional analysis, by the conversion for how many acres are in a mile squared. And I don't expect you to memorize that. That would be something you would be given in the problem. So it's usually have your problem, and then they were going to give you, I would give you the conversion. So like 1 mile square is equal to 640 acres. Okay. So then what we're going to do is, again, just set up our unit multiplier. So 1 mile square is going to go on the top because, I can't underline either. Well, stink. Can't do much anything in this, can I? Okay, never mind. The mile squared is going to go in the numerator, it's going to go in the top, and the acres are going to go in the bottom. And they go in the bottom because I want to be able to cancel out the acres. So you can see from this that acres is in the numerator here, it's in the denominator here. Whoops. So that way they cancel out. And if they cancel out, then, oops, don't do that. There. If they cancel out, then that's going to give me 75,000 divided by 640. And that's going to be miles squared. And the actual number that comes out to be is about 117 miles squared. Okay. All right. Example 4 is pretty much the exact same thing. So let's talk about measuring volume. So volume is length times width times height. So instead of a square unit, it's a cubed unit because we have length, width, and height all together. So let's look at example 6. So example 5 just looks at determining length times width times height, or finding the volume of a particular solution. So we're going to skip example 5 and go to 6. So a swimming pool has a volume of, can't spell volume, of 22,500 cubic feet. Okay, so cubic feet is the same thing as feet raised to the third power, or feet cubed. How many gallons of water does the pool hold? Okay, so again, we need a conversion that I do not expect you to memorize. That 7.48 gallons of water is equal to 1 cubic foot of water. Okay, so with that, I'm going to set up my unit multiplier, 22,500 feet cubed. And that's going to be times, now if I have feet cubed in the top, I want feet cubed in the bottom. So it's going to be 7.48 gallons over 1 feet cubed. Okay, so my feet cubed wind up canceling out because one's in the top and one's in the bottom. And then when I do the math for that, that's going to be 22,500 times 7.8. So 22,500 times 7.48, and that's going to equal 168,300 gallons. Okay. All right. So another thing that you need to remember, and you do need to memorize this. This is in example 7. Okay. So an aquarium has a volume of 3,600 cubic centimeters. A cubic, so if you took the aquarium and you measured its length, its width, and its height, it would be 36,000 centimeters cubed. And you need to know how many liters that is. Okay, so what you do need to memorize is that 1 liter is the same thing as 1,000 centimeters cubed. Okay, I do want you to memorize that one because it's a pretty easy one to use. Another way of saying that same thing is that 1 milliliter is equal to 1 centimeter cubed. Now, you may, if you listen to any medical shows or watch Grey's Anatomy or anything like that, you'll hear him say he needs 50 cc's of whatever. A cc is a cubic centimeter. So when they say 50 cc's, they really mean 50 milliliters. Okay? So that's why I wanted to bring that out and mention that and have you memorize that, is because that is something you hear a lot in your quote-unquote everyday life. And if you're going into the medical field, you will hear it a whole lot, because a cubic centimeter is the same thing as a milliliter, and 1,000 cubic centimeters is the same thing as 1 liter. Okay, so our example, we have 36,000 centimeters cubed, and we want to know how many liters that is. So again, I want centimeters cubed on the bottom so that it cancels out. So I'm going to have 1 liter over 1,000 centimeters cubed. So that, again, my centimeters cubed cancel out because this is the numerator, this is the denominator. And that's going to be 36,000 divided by 1,000, which is 36 liters. All right. So that brings us to example 8, and then we'll be done. So example 8 looks at, again, the medical field. and dosing of medication. So it says a physician orders 10 cc's of the drug Lexapro, which is used to treat depression and anxiety. I did not know that. Learned something today. Okay. To be administered to a patient in liquid form. So liquid form means they have to drink it, means milliliters. So we need two things. We need to know how many milliliters, I'm just going to put ml, of the drug should be given. Administered is the same thing as given. And how many fluid ounces of the drug should be given. Because sometimes milliliters is more of a metric unit, fluid ounces is more of an everyday unit. So you might have, if you're having to take this at home, you might not, nowadays they'll give a syringe that measures in milliliters, but you might not have anything that measures milliliters. You might have something that only measures ounces, and you need to be able to switch between the two. Okay, so what we're going to do is we're going to remember that 1 cubic centimeter is the same thing as 1 milliliter. So if he's ordering 10 cc's, that means that, so if we do our conversion, 10 cc's, that's cubic centimeters, times 1 milliliter over 1 cc, 1 cubic centimeter. So again, my cc's will cancel because one's in the top and one's in the bottom. And that's just going to be 10 milliliters. And then we need to know, all right, well, how many fluid ounces is that? Well, then you look up that 1 fluid ounce is equal to 30 milliliters. Again, that's a conversion I would not expect you to know. And then we just do the same thing. We set up our conversion, our unit multipliers, and we work it out. So we start with 10 milliliters because that's what we know. 10 cc's is the same thing as 10 milliliters. And since milliliters is in the numerator, I want it to be in the denominator. So I'm going to say 1 fluid ounce over 30 milliliters. That way my milliliters cancels out. That equals 10 divided by 30 is 0.33 fluid ounces. So you can see they're not the same thing. And you wouldn't want to mistake them for the same thing and say, oh, okay, milliliters, I can give them 10 milliliters. That's the same thing as 10 fluid ounces. It is nowhere near the same thing. You would be severely overdosed if you just made that assumption. So you got to make sure that your units are right. This is also a reason why it's so important to write down the units. And when a doctor writes a prescription or a nurse writes a prescription or a nurse reads the prescription, they have to understand and read the unit as well, because otherwise, if they're just reading the number, they, again, could severely overdose or potentially kill a patient because they gave them too much medicine or too little medicine. So you got to read the number and you got to read the unit both. Okay. All right. Well, that is it for 9.2. Okay. We'll work on some practice problems and doing these conversions in class.